In 1895, a geologist named James Dwight Dana submitted a paper to the American Journal of Science that has almost never been discussed since. He had spent 40 years cataloging the rock formations of the Pacific Basin, and by the end of those 4 decades, the numbers simply did not add up. Dana, who had served as a scientific observer on the United States exploring expedition beginning in August 1838, noticed something that he described, in the measured language of his profession, as a structural irregularity. The seafloor topography between New Zealand and New Caledonia did not behave like ocean floor. It behaved like the drowned foundation of something much larger. He noted the anomaly. He did not pursue it, and within 18 months of filing that paper, he was dead. That is where this started, not with a grand theory, but with a footnote in a 19th century geology journal that appeared in the bibliography of a book about Pacific Island formation, a book about coral reefs and subsidence, the kind of thing one only finds when looking for something else entirely. What follows is not a solved puzzle. It is a collection of documented details that, when placed beside one another, produce an arrangement that is difficult to dismiss and equally difficult to explain. The formal name for the landmass is Zealandia. It is not a myth or an inference. It is a geological designation, recognized in February 2017 by a team of 11 researchers working under the auspices of GNS Science in Lower Hutt, New Zealand. The lead author of that paper, geologist Nick Mortimer, described a continuous continental crust approximately 4.9 million square kilometers in area, roughly 2/3 the size of Australia, of which 94% now lies beneath the Tasman Sea and the Southern Pacific Ocean. The paper was published in the April 2017 issue of GSA Today, the Bulletin of the Geological Society of America. It was peer-reviewed. It passed without controversy within the scientific community, and it received, compared to almost any other continental discovery in recorded history, a remarkably brief moment of public attention. That on its own means nothing. Science journalism is inconsistent. Important findings get buried beneath news cycles every week. But Dana's 1895 anomaly was not the only early signal. Here is the detail that stopped me cold. Ferdinand von Hochstetter, an Austrian geologist who served as the scientific lead aboard the SMS Nevera during its circumnavigation from April 1857 to August 1859, conducted the first comprehensive geological survey of New Zealand South Island. In his formal report, submitted to the Imperial Academy of Sciences in Vienna in 1864, Hochstetter described the submarine ridges extending northwest from the New Zealand coastline as possessing a granite composition inconsistent with volcanic ocean floor formation. Granite is continental rock. It does not form on ocean floors. Its presence beneath shallow Pacific waters in 1864 was an anomaly that Hochstetter flagged, footnoted, and then, professionally and inexplicably, moved past without further comment. The report sat in Vienna. It was not translated into English for another 31 years. What does one do with that? Maybe nothing. Maybe Hochstetter had other priorities. The SMS Nevera carried naturalists, botanists, and naval officers, and the demands on a single geologist aboard such an expedition were considerable. There are simple explanations. There almost always are. But the pattern repeats with unsettling precision. In June 1971, Bruce Leyendick, a geophysicist then affiliated with the Scripps Institution of Oceanography in La Jolla, California, was conducting seismic profiling of the Southern Pacific when he recorded basement rock depths along the Lord Howe Rise, a submarine plateau extending roughly 1,800 kilometers northeast of Sydney, that were consistent with thin continental crust rather than standard oceanic basalt. His data were published in the Journal of Geophysical Research on March 10, 1972. Leyendick was meticulous. His measurements placed the crustal thickness at between 15 and 25 kilometers, thin for a continent, but far too thick for ocean floor. He proposed the term Zealandia, informally in a 1995 paper, 2 decades after his initial findings. Between 1972 and 1995, the data sat quietly in the literature, cited occasionally by specialists, invisible to the broader world. Once you see it, you cannot unsee it. 3 separate researchers across 3 separate centuries, using 3 different methodologies from 3 different institutional homes, arrived at essentially the same observation. Something large and geologically coherent existed beneath that water. Each one noted it. None of them built a career on it, and none of them ever gave a satisfying account of why not. The pattern repeats with unsettling precision in the archival record as well. The Royal Geographical Society in London maintained a running index of continental and island surveys from 1840 onward. A search of their archive catalogued, conducted through their fellowship reading room in the spring of 2018 by geological historian Gail Lomer, then completing her fellowship at the University of Edinburgh, revealed that 14 separate survey reports referencing anomalous crustal formations in the South Pacific had been cross-indexed under the category oceanic, not continental, at some point between 1870 and 1930. Lomer published her finding as a 3-page addendum in the Journal Historical Records of Australian Science on September 7, 2019. She framed it as a cataloging question, not a suppression question. She noted the reclassifications, but offered no theory about why they had occurred, observing only that the methodology for distinguishing oceanic from continental crust had changed substantially across that 60-year window, and that reclassification was administratively routine. She is almost certainly correct. Cataloging standards shifted. Institutional taxonomy evolved. The simplest explanation is often correct. And yet, those 14 reports were reclassified. Not destroyed, not hidden, but moved, placed under a heading that ensured they would not appear in searches for continental geology. The data did not disappear. The data was reorganized in a way that made it functionally invisible to anyone who did not already know to look for it. Once you see it, you cannot unsee it. Maybe I am seeing patterns where none exist. There is a well-documented human tendency to find architecture in what is merely sediment, to impose narrative on the coincidental. Dana was an old man near the end of his career and may simply have lacked the energy to pursue a finding that would have required years of follow-up fieldwork. Hochstetter was working under the logistical constraints of an 18th century naval expedition and cannot be blamed for not resolving a question that would require satellite-based seismic imaging to answer properly. Leyendik worked in a specialized subdiscipline whose findings, however significant, rarely penetrate the mainstream science press. And the Royal Geographical Society's catalogers were doing what catalogers do, applying the standards of their moment to records inherited from a previous one. These are not exotic explanations. They are the ordinary texture of how scientific knowledge actually accumulates, slowly, inconsistently, with long gaps between observation and recognition. The formal acknowledgement of Zealandia in 2017 is, by that reading, not an exposé. It is simply the conclusion of a very long process of evidence accumulation, finally reaching critical mass. But the geography textbooks deserve at least a moment of quiet attention. Between the years 1950 and 2000, the Standard Secondary School Atlas published by Rand McNally in the United States went through 11 editions. The 7th edition, published in 1978, included a single paragraph in its supplementary geological notes referencing the Lord Howe Rise as a region of ambiguous crustal character. The 8th edition, published in 1983, removed that paragraph entirely. No correction notice was issued. No replacement language appeared. The ambiguity was simply gone. The Lord Howe Rise became, in that edition and every subsequent one, a feature of the ocean floor. It may have been an editorial decision. Pages are expensive. Supplementary geological notes and school atlases are among the first casualties of space constraints. The simplest explanation is often correct, and yet something went missing. Not deliberately, perhaps. Not maliciously, almost certainly, but something that had been present. A small notation of uncertainty. A marginal acknowledgement that the South Pacific floor was not entirely what it appeared to be. Was absent from every classroom atlas for the next 4 decades. In the reading room of the Alexander Turnbull Library in Wellington, New Zealand, there is a shelf of survey documents from the 1870s that includes Hochstetter's original field notebooks from his 1858 South Island traverse. They are not restricted. Anyone may read them. The notebooks are written in a dense 19th century German hand, and they contain margins filled with measurements, sketches of rock faces, and small notations in a different ink. Added later, the archivists believe, possibly years after the original survey. Some of those later notations, according to a partial translation commissioned by the library in 2004, concerned the submarine extensions of the South Island's geological formations into what Hochstetter called the Drowned Valley to the northwest. The notebooks have been there for 150 years. They have been cited in 4 academic papers. Once you see it, you cannot unsee it. And then the question becomes not whether it was hidden, but whether the absence of looking is a kind of hiding in itself. Those notebooks still sit on their shelf in Wellington. The field measurements are still there in faded pencil, in a handwriting that took a translator months to decipher. A continent was recorded in those margins, imperfectly and provisionally, by a man who died in Vienna in 1884 without knowing what he had found. The paper is fragile now. The pencil marks are lighter than they were. What does it mean when the evidence for something was always present? And the question we are left with is not why it was erased, but simply why, for so very long, no one thought it was worth reading.